गुड मॉर्निंग फ्रेंड्स। आज हम एम.Sc फिजिक्स में सेमेस्टर थर्ड में माइक्रोवेव इलेक्ट्रॉनिक्स में सर्कुलर वेवगाइड पढ़ रहे हैं। सर्कुलर वेव कैसा होता है, फिगर में देखिए। इस तरह से एक ट्यूब होती है जिसके दोनों तरफ बाहर निकला हुआ रहता है, जिससे हम फिक्स कर सकते हैं, किसी दूसरे के साथ अटैच कर सकते हैं। एक मेटल का होता है। सो फर्स्ट वी स्टार्ट द definition of a circular waveguide. A circular waveguide is the cylindrical hollow metallic pipe with the uniform cross section of a finite radius. That is have a unique property of the circular waveguide. The TM mode propagation in the circular waveguide, the rapid decrease of the attenuation with the increasing frequency, due to which it is suitable for the long low लॉस कम्युनिकेशन लिंक्स। क्या होता है इसका अर्थ समझिए कि इसमें जो अटेन्यूएशन है वो जैसे जैसे फ्रिक्वेंसी बढ़ती है अटेन्यूएशन कम होता जाता है। इसके कारण इट इज़ सुटेबल फॉर द लॉन्ग लो लॉस कम्युनिकेशन लिंक्स, कि यदि एक जगह से दूसरी जगह तक बहुत लंबी दूरी का यदि हम कम्युनिकेशन करना चाहते हैं तो इसके द्वारा जोड़ सकते हैं, क्योंकि इसमें अटेन्यूएशन या लॉस कम होता है। नाउ we start the important topics for this one, that is the wave equation and its solution. What is the wave equations for the circular waveguide, and how it is used, and what is the possible solution of it. Today this is the main topic. So for a circular waveguide we can use cylindrical coordinate system because it is in form of the cylinder, and we very well known that cylindrical coordinate system are have the r phi z या r theta z, जैसा भी हम यूज करना चाहें, where r is called the radius vector which varies from 0 to a. A is the radius of the waveguide, and phi is angle vector that is in between 0 to 2 pi. These two forms the polar coordinate system, and the last z varies along the length of the cylindrical, that is the length of the tube. So the possible values of these three coordinates are in between the 0 to a, phi in between 0 to 2 pi, and the z that is in between 0 to l, where l is the length of the circular waveguide. If you want to see in this figure to plot these three coordinates, as per we know in earlier classes that r is the distance from the center of the cylinder, and that is called the radial vector, and it forms angle phi with respect to the x-axis, and its maximum value is up to the radius of it. इसे हमने ऊपर बनाया है टॉप में कि r जो है छोटी सी डिस्टेंस है, बीच में कहीं रेडियल वेक्टर और a इसकी मैक्सिमम वैल्यू है, and z is the distance from the bottom to the top, and that is the length of the cylindrical. So this is the to plot the graph between the r, phi and the z. Now the equations, as per we know very well, for the electric and magnetic field we are using the wave equations, और जिसको हम हेल्महोल्ट्ज़ इक्वेशंस भी कहते हैं, that is equal to del square E equal to gamma square E, and the del square H equal to gamma square H for the electric and magnetic field, where gamma is called the propagation constant, and it is combination of these two values alpha and beta, where alpha is called attenuation coefficient and beta is phase constant. और इसको यदि हम फॉर्म में रूप में लिखना चाहें तो रूट ऑफ द जी ओमेगा म्यू मल्टीप्लाइड बाय द सिग्मा प्लस जी ओमेगा एप्सिलॉन, वेयर जे इज आयोटा, म्यू इज प्रोबेबिलिटी, एंड द एप्सिलॉन इज द परमिटिविटी, ओमेगा इज एंगुलर फ्रीक्वेंसी, रो इज द कंडक्टिविटी ऑफ द मीडियम. The wave equation for the cylindrical coordinate system in general way we can write combined form, that is del square psi equal to gamma square psi, and if you use the cylindrical coordinate system then we can expand del square in form of the r, phi and z, and that is 1 by r multiplied by del r, and that is equal to of the r del psi by del r plus 1 by r square del square psi by del phi square plus del square psi by del z square equal to gamma square psi. Above equation can be solved using the method of separation of variables, जैसे हमने वहाँ पे किया था सिलेंड्रिकल कोऑर्डिनेट सिस्टम में, उसमें रेक्टेंगुलर वेवगाइड सिस्टम में सेम, वहाँ पे हम एक्स वाई जेड माने थे, यहाँ पे हम आर फाई जेड मानते हैं, दैट इज इन फॉर्म द कैपिटल, एंड दैट कैपिटल आर इज फंक्शन ऑफ ओनली आर, capital phi is only the function of small phi, and the capital Z is only the function of the Z. You can choose any three variables. Does not means that if you have the same symbols, that same is the Z and Z, and then the phi and the small phi. So if you are confusing, then you can use any three coordinate system. So the solution of it is the phi. So substituting the values of this phi into the equation second, we get phi z small r divided by del r, r capital del of the del capital R by the small r, plus r z by r square, del square phi by small del phi small phi square, plus r phi del square z by del z square, and the phi square size gamma square r phi z. Divide by the r phi z on the both sides, we obtain 1 divided by small r capital R del r multiplied by the small r del capital R by this del small r, plus capital phi divided 1 by the r square del square phi by del phi square 1 by z del square z by del z square equal to the gamma square. This equation shows that the sum of the all three parts is LHS equal to the constant. So the each part must be equal to the constant. If you multiply it by the r square on the both sides, then this will be give a constant value of it. So we suppose that let the third part, we use now the individual parts. 1 by z equal to 1 by z multiplied by the del square capital Z by del small z square equal to gamma g square. इसको gamma g लिख सकते हैं, propagation constant of the waveguide. Inside the waveguide you can see. So the del square z by del z square equal to gamma g square into z. In possible solution, because this is like the SHM, so possible solution of it, z equal to the capital A e raised to power minus gamma g, gamma small z plus b e raised to power gamma z. So substituting the value in equations, above equation third, we obtain the remaining parts. 1 by small r capital R del d by dr r dr by dr plus 1 by r square phi del square phi by del phi square plus gamma g square equal to the gamma. Now multiplying by the r square on the both sides, we obtain r small r by the capital R d by dr r dr by dr plus 1 by phi del square phi by del phi square plus gamma square minus gamma g square multiplied by the r square equal to the 0. You can be conscious about the two symbols r square and the gamma square, because both are the symbols just like that, same form. So please take care about it. The second terms of this equation fifth is only the function of the phi, so we can consider as equal to a constant. That is, let us suppose it is neta square. So solving these equations, we obtain del square phi by del phi square equal to minus neta square phi, and the possible solution of it, phi equal to a n sin n phi eta phi plus b n cos eta phi. Substituting the value of the eta inside this one, that is small r by the capital R d by dr r dr by dr minus eta square minus r gamma square minus gamma g square multiplied with r square equal to 0. Now the bracket these terms is use a new constant. We know that the cutoff wave number kc square equal to the gamma g square minus gamma square. So this equation converted like this one, r d by dr multiplied by the small r dr by dr plus kc r whole square minus eta square capital R equal to 0. So now this the combined equation is this, the whole equation is in form of this small r, other r, remaining are the constant. So it is known as the Bessel equations, and the eta and its possible solutions is given like this one. Capital R equal to the Cn Jn Kcr plus Dn Nn Kcr, where J and Kcr equal to nth order of the Bessel functions of the first kind, representing the standing wave of the cos kr for r is less than a, means inside this waveguide, and like this one, this is the values in between the minus 0.6 to the 1 we have plotted using this one j0, j1, j2, j3, इस तरह से खूब सारे symbols, and this one the on axis and y axis Bessel functions. For the details you can consult the method physics. And the next term nn kcr, function of the kcr is the nth order of Bessel function of the second kind, representing the standing wave of the sin kcr. ऊपर वाला जो तो फर्स्ट काइंड जो था, that is the standing wave of the sin cos kcr, and this is for the sin kcr, and it is for use r is greater than a outside this the waveguide. So the net solution of the wave equations is in given like this one, that r psi r theta z that is equal to r phi z, जिसे हमने माना था, इसको हमें तीनों के फंक्शंस मिल गए, तीनों के सॉल्यूशंस मिल गए, r phi z के सब्स्टिट्यूट कर दें, एंड फाइनली वी ऑब्टेन लाइक दिस वन, तो psi r phi z इक्वल टू द cn jn kcr plus bn nn function of the kcr multiplied with the an sin n phi plus beta n cos eta phi e raised to power minus j beta z. As per the diagram of the jn and nn, we can obtain it r equal to 0, means at the center of the cylinder kc r equal to 0, the function nn c can approaches to infinity, so that dn must be equal to 0, because यदि हम उसको r के सेंटर में बात करें, अंदर बात करें, तो उस जगह nn kcr इन्फिनिटी हो जाता है, इसका मतलब इसका जो मल्टीपल है वो 0 होना चाहिए, अदरवाइज because there will be the finite wave function inside this one. So to keep the finite, so at r equal to 0 at z axis solutions, we can obtain these equations only the cn function, so psi equal to cn jn function of the kcr, a n sin eta phi plus bn cos eta phi and e raised to power minus j beta z. अब हमारे पास में दो फंक्शंस रह गए इसमें, एक तो साइन फंक्शन है, एक कॉस फंक्शन. सो जैसे एक फॉर्मूला अपने लिखते हैं r इक्वल टू द एक्स साइन थीटा प्लस वाई कॉस थीटा, तो यदि r की वैल्यू चाहिए फिर तो रूट ऑफ दी एक्स स्क्वायर प्लस वाई स्क्वायर करते हैं, और यदि हम ये मान लेते हैं कि सपोज कर लें, मान लो कि x इक्वल टू कैपिटल ए साइन फाई एंड वाई इक्वल टू द ए साइन फाई लिख दें मान लो, तो जो रिजल्ट आता है आपका वो मिलता है हमें r equal to a sin phi cos phi sin phi sin theta and the a sin cos theta cos phi. So finally a cos theta minus phi लिखें या phi minus theta लिखें, कुछ भी लिख सकते हैं, because cos is the even functions. इस हमारी इक्वेशंस में देख के बात करें तो जो ब्रैकेट की टर्म्स है उसको हम रिप्रेजेंट कर सकते हैं, a n sin eta phi plus beta b n cos eta phi. Let us suppose a n equal to p sin theta and b n equal to p cos theta. So the p equal to a n square plus b n square, and tan theta equal to the a n by b n, theta equal to tan inverse of the a n by the b n. So finally we can substitute these values, and equation a जो ऊपर लिखी हुई थी उसको हम लिख सकते हैं p sin n theta cos n theta, p cos eta phi cos theta, and this is p cos eta phi minus theta, and इसका जो रिजल्ट p की जगह हम लिख सकते हैं a और b की टर्म्स में. So this is root of the a n square plus b n square multiplied by the cos eta phi minus tan inverse of the a n by the b n. And मान लो एक नया फंक्शन मान लेते हैं, root of the a n square plus b n square को f n. So the psi equal to f n c n j n k c r cos eta phi e raised to power minus j beta z, where psi may be the electric or the magnetic field component from the direction of the z. Now for the TE mode in central waveguide, we know very well that Ez equal to 0. So वहाँ केवल Hz मिलेगा. So Hz equal to Hz0 Jn kcr function of the kcr cos eta phi e raised to power j beta z, and the for TM mode of the circular waveguide Hz equal to 0. So वहाँ मिलता है हमें Ez equal to Ez0, Jn is function of the kcr cos eta phi e raised to power j beta z. So this is sufficient for today. Thank you.